Okay, I think we'll go ahead and get started. Let me go ahead and open this up in prayer. I guess it's about the season for this to potentially happen. We've had several students that have gotten sick. So I always appreciate when people reach out and let me know what's going on. So I'll be praying for them as well as after I pray, just get a chance to give you a sense of what we'll cover today. So dear Heavenly Father, Lord, I pray that you would be working in the lives of each of the students in this course. Lord, I pray that for those that are sick, several have had the flu or a cold or food poisoning, Lord, I pray that you would heal them. I pray that you would help them to recover quickly. And in general, for all students, Lord, I pray that all of the material that we're covering will be clear, and that they can see a clear connection between what we're studying and their objectives of what they would like to do in their degree program and getting the jobs of their choice. Pray that you would help them in their spiritual formation, Lord, that you would help them to really have an enjoyable and spiritually fulfilling time of studying scripture, of enjoying times in chapel, worshiping you, and also a chance to understand the theological concepts we want to be deriving from what we're understanding from scripture. Give them interesting and creative ways for faith integration. In Jesus' precious name we pray. Amen. Okay, well, our course is definitely moving along quite nicely. We're also getting to be about a little bit over a week before we have our Thanksgiving break. And so I'm also trying to anticipate that and seeing where we are in terms of how much material that we want to be covering. And so on Tuesday, we completed looking at the instruction set in assembly language with the ARM assembly language programs that you did. I think you got some interesting insight into that. The next thing that I wanted to spend some time today was to be talking about the central processing unit. And so we're going to have 4 chapters that are going to be covering that. And I think with the way that Stalling has organized this course, this gives a nice build up to things that we'll have. So I'm going to spend some time going over chapter 16. I won't finish that. And after I go over some of that material, I'd like to spend some time getting our Arduino kits set up. And so there's a specific project that I've shared that I talked a little bit about on Tuesday. There's the sample Arduino script and a PDF with some illustrations, and I created a video. So those are the things that I wanted to make sure that we cover today. So we're going to be talking about processor structure and function. And so there's things that I've slowly introduced, and I think it'll start to get a little bit clearer with some of the things that we'll talk about here. So first of all, we'll be talking about the processor organization. We've had some high-level charts that have looked at this, and we'll get a chance to be thinking about this in a little bit more in depth. We'll be talking about the register organization, that there's ones that are visible to the user. So those are the ones when we were using the Mars MIP emulator, we could see those 32 registers, but there's also other ones that help in terms of control and status. And those aren't necessarily ones that would be available to the user, but are important for operation. We'll talk about the instruction cycle, the fetch, execute, and get into more details about that. And we'll talk about some of the distinctions, but some of this gets fairly detailed. And so I won't go over everything, but to give you a general sense of the x86 processor family, how it has evolved, how they've expanded their instruction sets. And we'll also be doing something similar for the ARM processor. And then we get into this concept of instruction pipelining. And so we'll have some discussion in lecture. There's also a tool that I introduced probably about 3 or 4 weeks ago. I'm going to come back to that because now we're hitting this pipeline instruction, and this other emulator actually does a good job of giving you a nice visualization of what's going on there. So there's a variety of things that a processor does. It fetches instructions, it interprets instructions, it's fetched data, it processes data, and it writes data. And so these are the things that we have to be sure that we enable to make it do what we would like to do. So in order to do these things, the processor needs to store some data temporarily and therefore needs a small internal memory. So thus we get the justification for having registers. So we're going into that level, not just the von Neumann architecture, but we're looking inside the CPU. And as Stalin has pointed out, we see some similarities that with that von Neumann architecture, even within the CPU. We got a chance to be exploring of how we can be doing different type of operations, addition, subtraction, multiplication, and division. And so there's a variety of things that we need to do, shifting and having the ability to complement numbers. And then we also want to be doing the arithmetic and Boolean logic. And so having a 2's complement, we can actually do subtraction in a arithmetic unit. It's going to make it simpler. And we talked about how a shifter is another element that enables some of the higher level functions that we would like to be able to accomplish. So that's just a little bit of a reminder there. Here we talked about the registers. There's also some control. You need to keep aware of where you are in the execution of your program. Things like that have to be taken care of. So there's visible registers. So these enable the machine or assembly language programmer to minimize main memory references by optimizing use of registers. It's also going to be faster. We've mentioned that before. And then it says control and status registers, which are used to control the unit to control the operation of the processor and by privileged operating system programs to control the execution of the program. So we have these two different categories of registers. So for the user visible registers, there's their general purpose. It can be assigned to a variety of functions by the programmer. For data, we may use only to hold data and cannot be employed in the calculations of an operand address. So we see a slight distinction there. The address, it may be somewhat general purpose or may be devoted to a particular addressing mode. Last lecture, we went over the different types of addressing modes. Indirect is one of the ones that maybe not seem that obvious, but we've mentioned that, and different types of indirections. And there's also condition codes. Some of this would be under normal operation. Some of them would be if you have an issue that needs to be addressed, but a normal operation example could be that you have an addition and you have an overflow bit that you need to be able to manage. So those are some of the things that we address. There's also condition codes, and I've already talked about this some, and so I'm not going to dwell on this right now, but there are various things. And so if you want to be doing branching and a branching on a condition, this is the kind of thing that this is going to be able to help with. Compare. It's very common for us to be doing flow and having various types of looping types of commands or comparisons. And so this can be done at the assembly language level. And so it can be done within the CPU level. And so those are some things that are mentioned here. So what are the control and status registers? There's a program counter, there's the instruction register, there's a memory address register, and the memory buff register. So you need to be having a clear way of identifying where you are in memory, where you are in the execution of the program, and where you are with the instruction register. So those are all things that are available. There's the program status word, which it's a register or a set of registers that contains status information. And so there's various things that can be included in that status word. And here are just some examples of the register organizations. I'm not going to really focus on the 68,000 over here, but we'll be focusing on the Intel since we're looking at the Intel and the ARM architecture. And so this is what it was for the 8086. And so when I was in your shoes and I actually had to do programming, we actually got I think I had an 8086. So I had to build the hardware, and then I had to write the assembly language, put it into an EEPROM. And you might remember we talked about that earlier. And so it was really kind of clunky. I didn't have an IDE to really do this. And so these were the type of registers that I was using. And so these are all 16-bit registers. And then when you start to get into the next evolutions of what Intel did, starting with the 386, it actually had this way of doubling the size. And so now you have 32-bit registers. And so they stuck an E on this. They have to make sure that they maintain backward compatibility. And so you have enhanced, AX, EVX, etc. But it's still the general sense you have these kind of registers that are available, but now they're a little bit larger. There's other registers and program status things that are available. So we know that the basic flow of things is the fetch execute. We've also introduced that there can be situations where you need to be doing an interruption. As strange as it may seem, we've talked about it before, that there's ways how that can actually improve your overall performance rather than tying up a CPU when, say, there are some situations where it's having to wait for something else to take place. So you have the fetch execute. You have this interrupt mode where it can pause something and then go to another. We have this ability to have indirection. So registers can point to memory, or you can have registers pointing to one memory leading to another memory. There's various ways of how you can have indirection that can be laid out. So this just gives you another way of thinking about the instruction execution cycle. We've seen a chart like this. It gives you a state diagram that's kind of flowing into a little bit more detail. You need to be getting the instruction. You need to then figure out, well, what is the operand and get that. And so if there's an indirect, and so you have a value, have to make sure it's converted to binary before it's actually going to go to the CPU. And after you're done, you have to figure out the storage that has to take place. And also, as we had in this simpler figure, we have this possibility for interruption. So this is like a little bit more detailed diagram of what we saw in the last chart. So we have a handful of flow charts. When I was using Kummer, the previous textbooks, they had these charts that were a lot more detailed of going through the pipeline way. But so these are fairly high level, and I'll just kind of quickly go over them. But we can see how this is doing a data flow fetch cycle. And so the CPU is configured to be able to do those types of activities. And so if you just, if you're looking at these charts that I made available in Canvas, you could just quickly go through each one of these and just doing a comparison between that. We have the basic data flow and fetch cycle. We have an example when we have an indirect cycle. And so basically we have to figure out, well, what exactly needs to be loaded in for the instruction to be done. And so this takes figuring that out before you can actually do the execution. So you have pre-execution types of activities that are required. Here you have an interrupt mode, and so you have to take everything that you were doing, store it into memory, and then you do what is directed by the interrupt. And so these are some high-level ways of thinking about a couple different modes of operation. So what is a pipeline strategy? It's similar to the use of an assembly line in a manufacturing plant. And so maybe you've seen illustrations of that, whether it's like a car manufacturing plant. They want to keep it fully occupied, no delays, because everything is going to back up. if you don't have any, if you feel like to pretend this is a conveyor belt, you want to just keep things flowing with in a smooth way as much as possible. New inputs are accepted at one end before previously accepted inputs appear at the output of the other end. So basically, you're in that mode. You want to keep adding things up. You don't want to have any blank places show up in that pipeline. So to apply this concept to the instruction execution, we must recognize that an instruction has a number of stages. And this is where we start out with this basic idea, the fetch execute. So we mentioned that that's easy to comprehend, and we've looked at that. But then we can have the situation where what if nothing comes in? Then you're into this wait mode, and so you can have some things that are not as efficient as you would like. And so how are you going to start to figure this out? So you have a command that maybe has an intermediate, and so you have to do some pre-execution before you can actually fully execute this one item. That would be something that would start to slow down the overall assembly line, because you have something that you have to wait for, and so everything else is going to be backed up as a result. We're not going to get into some strategies to overcome that in this chapter, but that's something that we can be looking at. Okay, so here we see some more additional type of phases, and there's like some 2-digit acronyms that are used. And so the fetch instruction, the decode instruction, calculate the operands. And so let's say like we have an indirection, or we have an indirect register pointing to the things that it needs to work on. All of that needs to be figured out. Then you actually fetch the operands once you figure out what they are. And then finally, you do the execution. So you have to do 1, 2, 3, 4 elements before you actually do the execution. And then when you've done that, that's when you do the write operation. And at that point, you're ready to go on to the next command. So that just gives you an idea of what it would look like. So in terms of an assembly line, the pipeline, this would be a perfect world. You're going through all of these 6 items that we just mentioned here, and there's no break. So if we could do this, that would be wonderful, but this is the kind of thing that can start to happen. So you need to do a write, and let's say that it's taking a long time because of the memory is slower than the other things. And so as a result, we see like this bubble starts to form in what we're doing. And so that's not something that we want to have. So this is in all those different elements that we mentioned. And so we want to continue on. Is there something that there's a holdup? And so what are we going to do now? And so this is where we can see, well, one possibility is if we get into this holding mode, instead of just having the CPU not doing anything, we could actually branch to another instruction, maybe another program. And so this is going to keep your overall satisfaction of your overall computing environment. So this is starting to play some of these things out, how it can actually improve things. And we'll have some more of this in some later chapters that we'll discuss. So let me go back here, and I'll just stop sharing this for now, and let me go to one of the things that I wanted to share. So let me first go back to Canvas, and let me just get around the virtual room check. And so the things that I shared, first of all, I had an announcement, and so we have the video. So everybody find this video. Did you guys find this resource? You can either do a thumbs up or tell me via chat. Okay, so some of you did. So if you haven't actually looked in the announcement, This is the most recent announcement I put, so take advantage of that video. We'll also get a chance to see some of that live, and what I'm going to do in a few minutes. I'm just going to do a few more things before I get there. So, and then under project resource information. So as a reminder, what I've said on Tuesday, we were going to actually do this together in class. And so here is the program that this is a zip file that you want to be downloading. And so I would recommend that you go ahead and do that. If you don't have your Arduino kit, go get it. If you're not on a computer where you can't be doing that, go get your computer. So I'd like to make this be as productive as I can for all of us as we go ahead and do some things here. So let me just do a quick chart scan. Okay, I'm gonna skip some slides here, but so Thursday is more of our lab time. And so some of this are things that I can, I'll talk a little bit more about next Tuesday, but I'll be trying to give you an example of some of this here in just a minute. So we introduced these naming conventions. And so here is one of the things that you can be doing with a pipeline. And so you have a simple pipeline organization. You go through each one of these steps. We saw a couple diagrams where we're showing them how you have one command at a time and how you're doing it. And then this is in another area where we've seen that having cache can actually help us. And at times this may not seem obvious, but this can be helpful that if you have some of these times when you're waiting for something, you can actually fill in that gap. And so here is where that starts to be played out a little bit more. And so this starts to give us an idea of a pipeline organization that now is improved. And so I just wanted to get to that chart before I share something else. And so I'm going to restart this program, but with that one table. And here we have this way that it shows us progression going through this pipeline. And so this is the program that's running. And I know that the syntax is slightly different than what we used in the Mars emulator. And so that's one of the reasons why I'm not dwelling on this in too much detail. But so what this program does, it shows a way that you can be writing to the display with some more complicated type of formatted information. And so what this is going to do is just give you the version date of this program. I actually updated it to the current version that I have. And so like before, there's a data section and then there's a code section. The syscall is a little bit different, that you could actually do it all in one command. And so this is the format for here. And so there's just a few things that we're doing. We're doing an add immediate value to register. And so what we have is we're adding into a register a string. And so these are the strings. And so there's some things that are more complicated ways of assembling information that are added to an ASCII string. So this is the first one. This is how it's going to look like, but there's some wildcards that are going to be replaced. So that's the first command. We then have an SW command. So this is a shorthand summary of commands. And so SW is the store word command. So the when store that to a register, then we do another couple of these add immediate to this register, and we have this S1, so we're going to be putting in the month. We have this S2, which is going to be the name of the emulator. So that's we're manipulating the information and adding these things. So we then have another couple commands, and I think this is store data. I don't have it in my short cheat sheet. This is for the 32-bit ARM command set that I looked up, but let me see if I see it here in one of these things here. So there's Medic. Okay, well, we'll come back to that. So the main thing that I wanted to be giving you a sense of how this actually works. So we're manipulating to get the string into its final format. Then we do a print string, so syscall 5, and then we do a clean exit. So I'll just go ahead and reload this program. So I showed you this in a simple editor. It's not this version this emulator does not have a good IDE, but you can trace things in some interesting ways. So the first command is this dadd immediate, and so this will slowly increment here. And so if I start to do an execute single cycle, so what we see is something like what we had here in this perfect world example, that we start to load up this pipeline. So the first thing we do is a fetch instruction. So instruction fetch. So they have a slightly different nomenclature that they're using. So that's the first thing. And then we have the next step is the instruction decode. Instead of calling it DI, they call it ID. So if I do another single step, this first command is going to go to the next phase in this pipeline. So now what it is doing is it's doing this the instruction decode. So it's gone a little bit further in this pipeline. And so we're doing so we've now doing a store word, and we have gone to the next level for this add immediate. So those are the ones that we've kicked off, and we have the next one that's going to be coming in a second. So it looks like the third one has already been loaded up. So anyway, so you're starting to get an idea of this flow. So they have a color code for this, how it propagates through the system one at a time. So then we get a situation where we have a memory access, and this is where we start to, well, right here, we saw that there was a delay. We weren't able to add a new command because we had to do several writes, I believe, to make this actually work correctly. And so we finally get to the completion of our first command. And things are going okay. One at a time, we're getting to completion. But we're not as fast as we could be, because we could see that there was a log jam earlier in this whole process. Here's another illustration that we had a little bit of a log jam start to show up. And so this gives a visual representation of this going through the process of completing this relatively simple type of command. And it's only last that we get this. And so I just put in a date. I just used the 9th of June and put this to the current version. And so that's the result of that. So that's since we're talking about this pipelining, I wanted to spend a few minutes talking about that. Okay, what I'm going to do now is move next into the Arduino discussion. And so let me do around the virtual room. Does everybody have your Arduino kit? Everybody got it plugged in? Okay, either text me, go off mute, or thumbs up. Just give me some heads up. Okay, Ryan said he's having some problems uploading his code. Okay, well, we're going to get into that. This is some of what we're going to try and talk about today. So first of all, I'll just put this close to the camera so you can see this. So this is my setup here. So this is the wiring board, the white thing. And so what I did is I actually mounted my Arduino on the white on this board, this breadboard. And actually, it was real hard to put it in. This is a brand new wiring board. This is the first time I've actually used it. But with a little bit of patience, I eventually got all the pins in, because it's a new board that the pins are giving a nice contact, but you have to securely put it in. So I'm going to plug that into my with my USB, plug it back into my unit. And I've already uploaded the program, but what I'll do is just walk through this information that I have here as a precursor for giving you a sense of what we're doing. So this is what an Arduino looks like. So there's a couple ways that you could be doing this. You could put this into the breadboard like I did, and then you could have a wire next to it. Or you can actually put the wires in here and then just have your electronics that are hooked in on the whiteboard. So as a reminder, I'm using an Arduino Nano. I think Josiah is using an Arduino Mega. So there are a couple different types of versions that are out there. But this is just to give you a heads up, that's what I'm using. So it's really all you need to do is connect to 3 pins on the Arduino. And we're going to have 1, 2, 3 pieces of hardware that will hook up, and then we'll have some wires that we'll have to put in. And so this is what it's going to look like. And so this is why having this might be quite helpful, especially if a lot of the things that we're talking about are new to you. And so with your kit, you'll have a variety of different resistors. And so look for one that has this red, brown. That's going to be 220 ohms. And so we're going to be hooking up this switch. And then we're going to be hooking up this resistor to this LED. And so I can just walk through this a little bit, hopefully to make this a little bit clearer. So if you notice that these are all you can see that they're green. It's trying to give you an indication that all of these pins are hooked together. That's what this means. So on two ends, the top row, these are all hooked together. On the bottom row, these are also all connected together. So what we did is the first thing that we do is we wire this up to that. So we put ground. So as long as we stick a wire in one of these things, it's going to be getting this ground. So we put ground to this first pin, and then we have this put to D10. This little squiggly line and 10, that's D10. In a similar fashion, we're having ground put to one side of the resistor. Then we hook up the LED to one pin, and the other pin is we're going to hook it up to D2. And I know it shows you a 2. It doesn't have a squiggly line in front of it. And that's all that we need to have for this to work. So anybody give me a heads up? Has someone set this up? I tried to give you a little bit heads up on Tuesday to tell you that we're going to be going over this today. Anybody get this set up on their own time before class? Okay, good job, Ryan. For everybody else, please pull out your kit and let's get a chance to be doing that real time. You can get a chance to see how some of this works. Any questions or comments so far? Okay, the next thing that you want to be uploading to your Arduino is the program. And so I've shared this with you. I actually had a few more lines that I stuck in. And so this was me just doing some trying to vary things a little bit and see what would happen if we did that. And so some of them, it actually gives it some strange behavior, and I'll get a chance to talk about that a little bit. And if you're not familiar with these commands, there's a really good if you just go to the arduino.cc website, they have the documentation for all of the different commands. And so I just put that in the chat that you can look it up. And so these are the reference. So let's look at this one. So pin mode, I wanted to look at pin mode. Well, let me just start with, let's do the digital read and then the digital write to start out with. Then we'll have to find the other one. So the digital read, this gives you the format. And so basically all you have to do is put in a pin. That's all that's needed. And we can see that we put here, we just define variables. And so this is gives us, now we could actually have just put in the number here if we wanted to, but this is just a coding strategy that maybe you might like to do. And so that's how we do the digital write and the digital read. And then a digital write, let's look at that for a second. So it writes a high or a low value to a digital pin. So you notice it says digital. So basically it's trying to see if it's above or below a threshold, and depending on what it is, it's either going to put a 1, a high or a low, a 1 or a 0, however you might want to be looking at. And so that's what we do with that command. And those are the main ones that we have here. The pin mode, you're actually defining what you're going to be doing with those pins. And I'm not seeing it here right now. Maybe if someone else finds it before me, that would be great. That's okay. So maybe it's in another area. So under functions, and so this is what it configures the specified pin to behave either as an input or an output. And so you tell it what the pin is. And so we have our names, and then we put it into all caps. It's either output or input. And so this is a special type of inputs, an input pull-up. So and so those are the things that are understood by the Arduino. Okay. So so you can either have it. So here it just shows it as an output. So if I go to the digital pins, you have input, input pull-up, output. Those are the three possible things that you have. Okay. So I've shown you this before, but I with the driver that I'm using an Arduino Nano, and to get it to work on my Surface, I needed to download a driver. So it was a little bit more straightforward to doing that. I could do that on my Mac, but since I upgraded to a more recent version of the OS, it stopped working. And so this is the script, and it is hooked up to my Arduino. So the first thing you do is you want to, so mine is a Nano, Josiah is a Mega. Most of you are just going to have the Arduino Uno. You pretty much you could just use the default, what it does with the processor. Mine's on COM5 and it's configured on that. So if I get the board information, I get something back. That actually means that it's working, and so that's good news. I don't really need to be doing anything more. So so I think the only person that's given me some feedback is Ryan was having some problems uploading his code. And so the first thing I would have you look at, Ryan, is do you get something coming back when you go to get board information? Do you get something coming back to you like this? And if not, that's indicating that there is you're not. Okay. So what I would recommend that you do is first of all, disconnect your Arduino kit from your computer. Just disconnect the USB connector, and then close the Arduino IDE. And then restart the Arduino IDE. And then plug your Arduino Uno back into the USB connector. Okay, well, while Ryan is doing that, can I get some feedback from other folks? Is it working for you so far, or is it not working for you? Some of you, maybe you're already have figured all this out on your own, but some of you, since this is the first time you've ever touched hardware, I'm trying to go over this in more detail. Oates, is it working for you? Okay, Riley got it to work. Oh, wonderful job, Isabel. So hopefully I'm getting rid of the fear factor for folks. Kyle, is it working for you?
Yeah, it's working pretty well.
Okay. Enzo, is it working for you? Okay. So that's most folks. Oats may be having some comm issues. And now let's go back to what we're having with Ryan. So after doing that, is it working for you now? So the things that you would need to go back, you need to check, make sure that it's select to your type of Arduino, and the default would be checking the Uno. You most likely will just have to the processor. You can just leave it, and then you mentioned COM4. Does does the COM4 show up this time for you? Okay, I'll let Ryan work on that for a minute or two. Um, let me stop sharing my screen for a minute so you can see a little bit bigger. It's probably going to be hard for you to see this. But I'm going to push this button right now. The LED's off. Maybe it'll. So it's on. Give me a second. Let me try and move this closer so you can get a better look. So part of what this gets into is how do you do hardware troubleshooting? And we really, this may be the first time you've ever had to think about it. And so with software, we have nice tools like an IDE that helps us out. We can go single step mode. And so when we're doing things with hardware, we wanted to think of a way that we can be doing this that would be helpful. And my video actually shows you that my switch actually kept coming out, and I had to straighten the legs so it actually got a better connectivity. And so I just lowered the display so you're seeing my setup right here. And so let's see how it works. Okay, I pushed the button and it came on. You saw it did flicker a little bit, and I can come back to that. Push it again. And so in general, it does work, but maybe it doesn't work as well as I might like. And so there's a couple of things in the code that I'll just talk about next to give you a perspective on. So I'll go ahead and start sharing my screen again. But anybody try that on theirs, and do you get it to turn on and off at least some of the time? Anybody want to give some feedback on that? Okay, I'm not seeing any thumbs up, so I don't know if that means that nobody got it to work. Oh, okay. All right. Well, I'm glad that people are making some progress here. Just especially if this is the first time you've ever done something like this could be the basis for your first of 3 projects. Maybe you just do some slight modifications to this. So Ryan, I'm not quite sure why it's not working. And so let me just ask you a different question. Have you ever got it to work before? One of the things I had as an earlier example was you don't plug anything into it. You just plug the Arduino kit in and you see if you could get something responding back from the get board information, the get board info. Okay, so what it means is it sounds like you may not have the driver set up. Okay, so at least you're getting power. And so this is kind of an illustration of some of the troubleshooting that one needs to be thinking about. Well, I'll come back to that, Ryan, and maybe if you bring your kid on Tuesday, we can try some of that, some of our time there. So Josiah is asking what resistor should we be using? And so the 220. And so what the kit will actually come up with, there'll be like if it's like what I had, you'll have different set of resistors that'll be put together. So I'm looking at my grab bags of stuff here. And so you'll probably have something like a bag like this. And this is another shortcut way of maybe helping you out. That sometimes they have a label on them, so you don't have to try and figure out the color code. Trying to show you an example. Yeah, these are kind of faded, so I don't really see but sometimes they'll have like a little number on them on the end on the where they're connected together that'll tell you what value it is. So, but basically you want to get a red brown if you can. So that's okay. Well, good job, Josiah. So so it sounds like we got most everybody. They got their kit that they're pulling out, putting together. A lot of you have actually been able to go the next step, and you're actually got the sample project working. And but some of you still have problems. I know, Ryan, you're having some challenges. And this is where you get into a different kind of frustration that you have to figure out how to manage. I put it this way. Now, I have a picture here of my setup. And so when I was doing mine, I told you that I had problems with the switch. Another thing I had is I actually had put the yellow and the blue wires in the wrong spot. I had them reversed. This was me trying to do that translation going from how it lays it out in an Arduino Uno, and I was in an Arduino Nano. So Josiah might have this kind of a challenge. And so we'll just work through that together. There's another piece of test equipment that I have. It's called a voltmeter. And so I was actually able to check the voltages and was able to troubleshoot some of the logic of this. And then that's when I started to figure out, oh, okay, what's happening is as I then double checked the wires, and I found that they were reversed. And so this is what I meant, that you can actually plug this into the breadboard. I know one of you guys were mentioning in the chat board in Canvas that you were talking about an LED display. I haven't gotten into that, but depending on how we go with our time in class, I can actually build up an example and show that to you. But for now, this is probably a little bit more basic for a way of just starting to have you get familiar with putting things into this breadboard and seeing how that works. So let me open the PDF, because there's another thing I can show you that I also included in the video. Wrong one. So they have a blow up picture of the switch, and you can see how these are bent a little bit on two sides. And so you want to have those, so the bent ones would be towards the middle and the other two bent ones on the top. And if you have problems that this doesn't seem to be very secure, you just have to get a pair of pliers. You can straighten out those legs. So straighten out this bend, and you'll have a little bit more real estate that you can stick into the wiring board and make it a little bit more secure. Okay. So we're actually just using one side of this switch. And so when we put it down, we're actually causing this pin to go to ground, this yellow pin. So this now gets into the logic of what's going on. And so let's just pretend like you're trying to have a new capability for a cell phone, and one of them you're using a switch, or maybe like what I've always tried to talk about with your project work is trying to do some risk reduction. So it may not be exactly what you want to do, but it's a scaled down version that you could start to be thinking through the logic. And there's a command here called a delay. And one of the reasons why they have is like you hit a button, and does it start ringing or something like that? And I was trying to show you a little bit of an example. You saw when I turned it on or turn it off that it didn't actually do exactly what I would like it to do. And so I may actually have to play a little bit more with that delay setting. And that was one of the things that I was looking at before. But let me go ahead and try something. So I have this program. I know Ryan was having problems communicating with his Arduino. So one of the things you can always do is reload the program. And so the steps I was mentioning to him about disconnecting the Arduino, closing your IDE, and then plugging back the Arduino, and then restarting your IDE, I found that that's one of the ways that can start to help fix things. And so that would be a strategy that you may want to give a shot. So let me just do another check. Any other comments or questions that people have? So Ryan, can you just confirm that you'll bring your kit next Tuesday, and we can see if we can troubleshoot this together? It'd probably be better having me right next to you. And if you're there for a few minutes early for class, that would actually be better. Okay. Right. So everybody else, is this a positive experience now, kind of breaking the ice with your Arduino kits? Okay, good. And I know Isabel, I know you were pretty scared about this. Now you can see it's not so overwhelming. And also, just to give you a heads up, they're pretty resilient little kits. And you also have a lot of different components. And so we'll get through it together. And I think my experience is a lot of people enjoy actually doing this. And so we'll see how that goes for everybody. Well, I think that's a good breaking point. So I'll just finish up with just a few more thoughts. So have actually been covering a lot of ground thinking about processors. And so thinking about computer architectures. And so we're now just focusing on that next step, getting into the weeds. And Stalling does this a lot. He has kind of gives you a nice overview. And I think at the very beginning, Like I think the first chapter and the third chapter were actually pretty long, but then the later chapters get a little bit more manageable. And so in the time remaining, we're going to get into thinking in more depth of the CPU. And just like with the memory and having things in the von Neumann architecture, having like caches and things like that actually improve performance, we're going to be figuring out how we can be taking this basic architecture. Oops, got to go to the right chapter. And we were showing a perfect world type of pipeline execution flow. And unfortunately, this is not how it really works. And so how do we start to make it as close as possible to do this kind of a flow? So if you're having to wait, well, maybe you do another command while you're waiting for that. And so you kick off something while you're waiting for something else to complete. We'll be talking about that. Then another thing that we're going to be getting into is that now it's quite common that we have computers that have multiple core processors. Well, do they all have to be the same type of core? This is maybe something that hadn't occurred to you. Is the answer is no, they don't have to be all of the same kind of a core. You can have, say, ones that are more good for media, some that are more good for computation, others that are more optimized for general use. And so we'll be thinking about that. And so this would be another little snippet for the very end of the class. So anyway, I look forward to seeing you all next Tuesday. And if any of you have any questions or comments, we'll set up some time. I do have my office hour on Wednesday, but Monday and Wednesdays are times when I have my schedule is open to do something that would work with your schedule if Wednesday mornings don't tend to work well for you. All right. God bless you all. Have a good rest of your day.
Have a nice day, Professor.
Thank you. I just got mine to work, by the way. So
Oh, good job, Josiah.
see you next week.
All right. God bless.